Okay guys, we made it to Unit 9. We're going to talk about square roots in this first unit. It's nice and easy, and I'm going to teach you how to simplify square roots, and you're going to have a day tomorrow to practice that on your own. So if this first lesson seems a little tricky, you have an extra day of practice, so don't worry. So square roots, cube roots, and higher level roots are super important mathematical tools because they are inverse operations to squaring and cubing. In this unit, we will study these operations as well as numbers that come from using them. First, some basic review of what you've seen before. So we're just going to find the principal square roots and writing a reason. Principal meaning, we've discussed before that when you have a square root, you have a negative and a positive one. So when they say principal square roots, we're talking about the ones that are positive here, okay? So the square root of 25, well, we know 5 times 5 equals 25. So the square root of 25 is 5, right? And this was 5 squared, sorry. Square root of 9. Remember, we're thinking of what times itself gives us 9. 3 times 3, which is 3 squared, equals 9. So the square root of 9 is 3. If you want, you can pause this and do the rest of these on your own. I'm going to keep going. Square root of 100, 10 times 10, or 10 squared, is equal to 100. So the square root of 100 is 10. 0, this one's easy. 0 times 0, or 0 squared. 0 is its own square root. 1/4, remember what we discussed? It's basically like doing square root of 1 over square root of 4, which is 1/2. 1/2 times 1/2 is equal to 1/4. So the square root of 1/4 is 1/2. And 64 over 9, remember, it's like square root of 64 over the square root of 9, which is 8 over 3. So if you did 8 over 3 times 8 over 3, you would get 64 over 9. So the square root of 64 over 9 is 8/3. Okay, so this is a review. Hopefully you didn't have any difficulty with that, because hopefully you remembered it. Now what we're going to talk about is the fact that square roots really have a negative version as well, because when we multiply two negative numbers, we always get a positive. So when we take a square root, we have to account for that. So technically, square root of 4, when we think of it, we think of 2. But negative 2 times negative 2 is also 4. So when we find a square root, we really have two answers. So the square root of 4 is actually 2 and negative 2. Okay, and the way that we usually show this, and I did show this to you guys once before, is plus or minus 2. So that shows in one little number, positive and negative 2. So using that for 36, the square root of 36 could either be 6 or negative 6. So we write that as plus or minus 6. Okay, and now 1/16, the square root of 1/16. Remember, you like to break it up, square root of 1 over square root of 16. So that's 1 over 4, but it could also be negative 1 over 4. So just like the others, this is going to be plus or minus 1/4. That's how we write both of the roots. Okay, guys? Super important to include that plus or minus. Just makes it much easier. So what we're going to do is we're going to look at a function f of x is equal to the square root of x plus 3, and we want to find the value of f of 46. Remember, functions always work the same way. So when you're given an input, you plug it in. So I replace the x with 46, like this, and that gives me 49. Okay, so this is going to be square root of 49, which is 7. I'm not doing my plus or minus here because it's a multiple choice and I can see that I only have positive values. Okay? All right. Square roots have an interesting property when it comes to multiplication, and we will discover that property in the next exercise. So this is going to lead us into something cool. So we're going to find the value of each of the products. Square root of 4 times the square root of 9. And we're going to use the principal ones here, okay? So the meaning positive. Square root of 4 is 2. And the square root of 9 is 3. So 2 times 3 is equal to 6, right? Cool. Let's do B now. The square root of 4 times 9. This time we're going to do the multiplication first inside. 4 times 9 is 36. And now the square root of 36 is 6. Interesting. What do I notice here? I got the same answer when I multiplied the two of them separately and when I multiplied them together and found the square root. Let's see if that same thing happens here. If I take my square root of 4, that's 2, and my square root of 25, which is 5, I get 10. And let's see what happens if I do it this way. 4 times 25 is 100, so the square root of 100, holy Hannah, it's also 10. This is a super important property of square roots, and we're going to take a look at it in algebraic form here. You can take two square roots that are separate, and you can put them underneath the same square root, and you get the same answer, okay? So they are interchangeable, just like we just saw. So sometimes we can use this to help us where we don't know the perfect square. So Kirk is calling it unfriendly square roots. So for example, what you have here is the square root of 2 times the square root of 8. I don't know the square root of 2, and I don't know the square root of 8. So that's not going to help me. However, if I use this, and I pop them both underneath here, and I do the square root of 2 times 8, it's going to help me out immensely, because the square root of, 2 times 8 is 16, and I know the square root of 16 is 4. How delightful is that? Here again, I don't know the square root of 12. I don't know the square root of 3. However, 12 times 3 on the inside here gives me 36. And that's a nice answer of 6. Okay, uno más. 20 times 5, I don't know the square root of either of those. But when I put them together under the little roof, I get the square root of 100, which is 10. Now, it doesn't always work out that nicely, but sometimes it will. So here's the main thing that we're going to learn about today, the most important thing, and that is simplifying square roots of non-perfect squares. Even though I said I don't know the square root of 8 or the square root of 12 or the square root of 20 here, I can simplify them. This is a fairly antiquated skill that's almost completely irrelevant to algebra, but it often arises on standardized tests and thus is a good skill to become fluent in. I think that we went over this when we did co-op prep, but I can't remember, so I'm going to just completely start fresh again. So to introduce simplifying square roots, we're going to do this first. Okay, so this is walking us through it, and then I'm going to show you my way, which might be a little different. So first thing we're going to do is we're going to list out the first 10 perfect squares. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6, 36. 7 times 7, 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. Those are our first 10 perfect squares, okay? What we're going to do is we're going to be using our perfect squares to help us simplify the squares that are not perfect. For example, the square root of 18. What I want to think about when I simplify a perfect square is are there any actual perfect squares that are factors of the number in here? In other words, I can divide this number by that number. So I'm looking at 18, and I'm looking here, and I'm thinking, what can I divide 18 by that's a perfect square? And I should notice that it's 9. Okay? So we're going to actually simplify this. What you do is you take your square root that you're trying to find, and what we do is we replace it with the product of the perfect square that we can divide by and whatever else we can multiply by. So think about it off to the side if you need to. 18 is equal to 9 times 2, right? So that means that the square root of 18 can be written as the square root of 9 times the square root of 2. And then you simplify your perfect square. So the square root of 9 is 3, and you leave the other one on at the end. This number is the square root of 18 simplified. It's actually pretty easy in that simplest radical form. So you're going to spend all day tomorrow practicing this, so don't worry. The key to simplifying any square root is to find the largest perfect square that's a factor of the radicand, which, by the way, is the term of what we call the number underneath the square root. So we're going to take a second to find each of the square roots in simplest radical form. So let's do 8. So you want to think about what is the largest perfect square I can divide 8 by. You can always write it off to the side if you want to. 4 times 2 will give me 8, right? So I take my square root of 8 and I rewrite it as the square root of 4 times the square root of 2, and I simplify my perfect square. The square root of 4 is 2. So this is 2 radical 2. And you can say rad 2 if you want. That's my answer. Let's try 45. So 45, you can look at your list, but most of the time it pops into your head. 45, I know I can divide by 9. 9 is a perfect square, right? So 9 times 5. By the way, you always want to put your perfect square first, because then you get the coefficient in the front. So 9 times 5. So I'm going to take my radical 45, and I'm going to rewrite it as square root of 9 times the square root of 5. So the square root of 9 is 3 times the square root of 5. That's my answer. I know some of you guys are going to love this. All right, 48. Here's one that's a perfect example of needing to be careful, because a lot of you might be thinking, 4, I can divide by 4. But there is a larger one, so be careful. You want to use your calculators for this. If you don't know, you're going to get big numbers sometimes. You really want to go in your calculator and try dividing by square roots so that you can see if you really do have the largest one. If you don't have the largest one, then your answer is not going to be fully simplified. So in this case, hopefully some of you know, this can actually be divided by 16. 16 times 3 will give me 48. So I take my radical 48 and I rewrite it as the square root of 16 times the square root of 3. So this becomes square root of 16 is 4 times the square root of 3. So it's 4 rad 3. Now notice in the first example I wrote out the multiplication sign. You do not have to write it. It's just like variables. If they're written together like that, it's assumed that they're being multiplied together. So 4 rad 3 is your answer here. Okay, now I'm going to let you guys try these 3 on your own. So you can pause and try these and unpause and come back to check the answers. Okay, so here's the solutions. Just be careful if there's a negative outside. You have to bring that down. Can't forget about it. So for the negative square root of 75, you take a look at your square roots and you know you can divide by 25. 25 times 3 will give you 75. So you break it up, keeping the negative outside. Square root of 25 times the square root of 3. This gives me 5, keep the negative outside, square root of 3. For E, 72 is another example where you may have jumped to the conclusion of 9 times 8. One thing I should say is if you ever do that on accident, you can always just make sure when you get your final answer that your radical in the house can not be not to be divided by any other perfect squares. So for example, if you did square root of 72 is 9 times 8 like this, you would get 3 radical 8. To stop and make sure, wait, hold on, I think I can simplify 8 because I can divide 8 by 4. That means you didn't fully simplify this. You don't have to start over though. You could actually keep going and simplify this 4 times 2. And then this would be 3 times 2, square root of 2. And you'll end up with the same answer. Just a side note, okay? Because it is easy to accidentally use the wrong square root. My suggestion There's a very limited number of perfect squares, so I don't see anything wrong with just plugging it into your calculator and dividing it by the perfect squares just to make sure. And if you do that, you'll find that it's 36 times 2 here, which reduces to 6 rad 2. And finally, F, that one was kind of easy, just remembering to keep that negative outside. 500 breaks up into 100 times 5. I know I can't divide 5 by any perfect squares, so I know I did this correctly. Keeping the negative outside, I get negative 10 radical 5. That's it. So tomorrow you guys are going to do just straight up practice with simplifying square roots. You do have to know that skill going forward in pretty much every high school course, so it's very important. Even though Kirk said it is almost completely irrelevant to algebra, it does need to be done, and it is on standardized tests. Okay, so if you have any questions about simplifying, let me know, and I will get back to you as soon as I can. All right, have fun.